Oh, this is Mrs. Ballard again. I apologize about that little delay in the break in the video, but had some kids in here bugging me. So we're gonna go ahead and keep going. We're gonna do this same process. This next one's a little bit tricky and interesting. Um, so let's go ahead and see what we would do with it in Desmos. I did take the opportunity to add some tables in here for myself. You guys can go ahead and just sketch them in there yourself too. So I am going to graph this in Desmos the way it looks. And again, ooh, sorry, it's jumping all over the place. It's f of x equals 2, and that kind of seems really weird. But it said that at 1, it said that at -1 there wasn't a value. So I need to actually indicate that in there. So what I'm going to do is I'm going to draw a point. This really is kind of fudging it a little bit. I'm going to draw a point at -1, 2. See that point that popped up? And I'm going to fake it and kind of put a hole there. Now, this really wouldn't pop up if I put in f of -1. Sorry, the caps lock came on. F of -1. I'd still get a value. So I'm really not truly doing this the way I should be, but at least can kind of get a picture of it. And then it also said in here that we had at the x value of -1, it was 0. So I'm going to put that point in as well. So at least you can see a picture of it. So at -1, the y value is 0. So you see that's what my picture is going to look like. Now, I could go through the routine of what's going on either side of -1. So I'm going to say f of, let's see, just to the left of -1 is -1.99. And then I could add another, or sorry, 1.9, and then I add another 9 and add another 9. And you'll notice it's always 2, right? If I went to the other side, it'd be -0.9 and 9, 9, and 9, 9. So in this case, everything is 2. So I could add my x value. I know that I am approaching -1. So I'd have -1.999, -1.99, and -1.9. And then -0.999, -0.99, and -0.9. And we just realized that everything is 2. So I know that my limit, so I'm going to rewrite that, is f is definitely 2. So limit as x approaches -1 of f of x equals 2. And again, to prove to me you did it, I would go ahead and sketch the graph, make sure you got a hole in there and the closed dot there. Probably good to put arrows on it here, even label X and Y if you want. Okay, let's try another piece here. So I'm going to go ahead and, well, first of all, let me figure out what X values I'm supposed to be approaching from both sides. So I know 0 is what's going to go in the middle. So just less than 0, the closest I could get to 0 without going positive would be -0.999. So I'm just going to back off my 9s there. And then just bigger than 0 would be 0.001 and 0.01 and 0.1 would be just bigger. So those are the x values that I'm going to put into my f value in Desmos. So absolute value of x over x is what I'm going to graph here. So I'm going to get rid of what I had before. So f of x equals the absolute value of x divided by x. An interesting graph, okay? And we're going to go ahead and put our values in there. So f of negative, I put the wrong number, didn't I? Negative, it should have been a 0.1, sorry. And then if I put a 0 in front of it, it shouldn't have been 9 nines, it should have been 1s. All right, and then put another 0, it's still -1. And then if I put in 0.1, it's 1. And if I put in a 0 in front of that, it's still 1 and still 1. So let's go ahead and record that. So I need to fix this. These should have been -0.1, negative 0.01, and -0.1. All right, and we said all of these turned out to be -1, and all of these turned out to be +1. So in this case, notice as I'm coming at it from the y value from the left and the y value from the right do not match. So I know that this limit does not exist. All right, I put my chart for this one over here. So we're going to kind of look to the left here. Okay, we're going to 0, and I'm going to use those same values as in the last chart. Just to the left of 0, the most left I could do or would be negative 0.001, negative 0.01, and negative 0.1. And then just this way would be 0.001, 0.01, and 0.1. All right, let's go ahead and put that into Desmos. So I'm going to say f of x equals, and we have sine of 1 over x. Oh, look at that craziness. So it's going to be interesting to see what happens on this one here. As we really can't tell, it's kind of oscillating up and down there. So we're going to do f of negative 0.1. Make sure you record that. Okay, and f of negative 0.01. And f of negative 0.00. It looks like it's definitely going to something though. Look, it jumped from 0.5s to 0.8s. All right, let's check the other side out now. F of, notice I didn't just do my repeat over the top, so I'm going to go from the other direction. 0.1. And then f of 0.01. Interesting pattern again. Looks like symmetric numbers. All right, and I got 0.826. All right, so let's go ahead and record what I got there. So I've got 0.54, and I'm just going to go 3 decimal places, 4.506, and then it went 0.8. It went negative, actually. Did it go negative? I can't remember. It did go negative 0.826. Okay. Negative 0.826. And then from this direction, it went negative 0.5. Interesting. Similar numbers, but opposite signs. Oh, I didn't get that one. Sorry. I'm reading it off of a sheet here because my thing disappeared. It was negative 0.544, negative 0.506, and this was positive 0.826. Well, since these are both approaching different values, that means that that the limit does not exist on this one. So we would say that this one also does not exist. All right, so we're going to talk about 3 reasons why limits fail to exist at C. So if f of x approaches, I'm going to flip this again, a different number from the right side of C than it approaches from the left side of C. So that's one reason it fails to not exist. This is often called a jump discontinuity because it makes a jump, and we didn't draw our graphs, did we? We saw that going on because I didn't draw the pictures. This one here was something like this, right? Something like that. And then this one it was going to go crazy like that, right? It was oscillating all over the place. Okay. So this run right here would have been an example of that first one. Example of number 1. Okay. Either increases or decreases without bound as x approaches C. So either increases or decreases without bound as x approaches C. That means it either approaches infinity or negative infinity. And I don't know, did we see that on any of these? Not on these ones. We saw that up here, though, with some of these limits increasing or decreasing. So this one would have been an example of number 2, example 7 there. And then the last one is f of x, and you've heard me say this word a few times, it oscillates between 2 fixed values as x approaches C, and that's really what's going on with example 11. This is an example of number 3 right there. So in examples 8 and 11, you discover that 2 of those limits do not exist. discuss. So you should take some time and do this if you want to pause it. We kind of just talked about it. So I'm going to keep going. So this one is example. We said that example 10 does not exist because of reason number 1. And example 11 doesn't exist because of reason number 3. All right, we got one last question to do here. And just a little side note that older AP questions have 5 choices and your test is only going to have 4. So this one happens to be an older one. They're still good because they're at the correct level for you to practice at. And we're going to keep throwing them at you. So this was actually a multiple choice question. It was actually on the 2014 test. When I ever see something like this, when it asks me which of the following statements are true, I just go through each statement individually and try to figure out true. I ignore these answers at the bottom until I've gone through and decided true and false on my own. So it says the limit as x is approaching 2 from the left. So 2 from the left, it looks like the y value is -1. So this is -1. And then it wants f of 2. So f of 2, if I look at the actual value at 2, it also happens to be -1. So I would say that that's true. Okay. And I am going to erase my scribbles on the graph. I'm trying new buttons here. All right. 6 from the left. So 6 from the left looks like it's going to -1. 6 from the right looks like it's also going to -1. So it appears that this is also a true statement right there. Then it's asking me about 6 overall. We just learned that it's -1. But then it's asking me about the value at 6, and because there's a hole there, I know there's a dot right there. I know the value of 6 is -3, so those are definitely not equal, so that one's false. So my answer has to be that it's 1 and 2 only. And that concludes our lesson for the day.